Academy Foundation presents the partial Cauchy. Cauchy surfaces are pseudo-Riemannian Lorentz manifolds. We ordinarily presume a manifold is a space that belongs to something and within a temporal metric. Lorentz assigned a manifold to the metric 2. This metric is uniform, sharing the same point in time, an indivisible unit with constant effect. Both spaces and metrics have opposite pressure or volume, linear or angular qualities. A hypersphere consists of more than 3 dimensions that are subject to 4 contextual evaluations relative to each other in the flow of time. Volumes and spheres are defined by linear or angular values. When they are mixed together in a bicomplex, one is linear, the other is angular. The Cauchy is not directly evident here except as shaped dilation. In other words, it is defining the metric giving scale and symmetry qualities to space. Dilation is the instant of time, a subset of space-time. It limits flow by applying pressure but is not the flow or relative positioning consistent with past or future. Lorentz manifolds are commonly used to analyze differences in reference frame. Because the Cauchy hypersurface is achronal, the entire effect shares the same point in time. This form of analysis only applies to the causal function for the hypersurface. The initial conditions define shape. They are a function of the third law. In this case, the effect is caused by a volume of moving masses. Mass in motion has variable velocity. The hypersurface has a fixed speed. Conversely, galaxies in clusters like the coma cluster flow as lines called filaments. Filaments draw out dilation in the form of volume diverging out of focus. On more humble levels, the kinetic energy defines things like surface tension, hardness, cohesion, and viscosity. Equal and opposite must be read with extreme caution. Clausius-Virial theorem provides the kinetic energy value. Momentum is inextensible, meaning it is confined to the members of the group where it is shared. The equal and opposite of that effect is dilation being the temporal focus at the center of gravity for the group. The presumption is objects form a common orbital plane like a solar system or spiral galaxy. The alternative is a helical pattern of revolution as with our solar system in the Milky Way. This helical pattern revolves around the galaxy like the cab of a Ferris wheel always facing the same direction, which adds a backwards tumble to the helix. This complex pattern is consistent with the bar spiral effect. The shaping affects how value applies into the two-sphere mode. A linear hypersurface wraps relative to input around the equator and ultimately squeezes value out of the poles. An angular hypersurface has value pressing into the poles, so it wraps longitudinally and emits value in ring pulses around the equator like the Crab nebula. Generalizing loses details. White light subjected to a prism reveals absorption lines. Even this is a generalization because the radiant values have polarization features that make EMR look like a topographical map. This is easiest to see in CMB where the values are differentiating. Bicomplex principles apply here as they do with color and flavor charges. The mixing angle connecting applied and imaginary axes into a bicomplex determines polarization. As we saw with the Crab nebula, the input streams were spread wide, splitting into twisting and gyrating arms. Energy focused tightly has high dilation. Naturally, these can reverse roles. Focus depends on the ability to shepherd all the momentum into the most constrained toroid. A ring will interact first locally, forming a gyrating flow as things orbit around each other as they revolve around the ring. When the initial conditions are tight enough to interact across the width of the hole, it is easier to take on a linear transformation. Exclusion applies when the opposite volume constant has been filled, forcing the effect to mix and emit the standing value. The nature of the momentum determines which constant is defining the field equation. The Schwarzschild is the two-sphere radius, which is the available volume. Here it is given in one sphere as permittivity, describing how space allows value to apply. It occurs at the event horizon where mass is robbed of its temporal quality and the emittable value is confined to the volume. The stress-energy tensor is the presumptive linear form provided in Einstein's field equations. This conveniently linked the general effect to the Gaussian distribution form of Newton's inverse square law. The generalization is easily misconstrued as being a uniform field to the geometric origin, which overlooks specific types of gravity between. The angular equivalent is permeability, which is how value applies to space. The only real difference is the axis. The rotation or mixing angle at the bottom is where the two axes ideally intersect. Gloaming variations continue to baffle researchers trying to isolate Newton's constant to one number. It's hard to measure an angle you can't directly observe but ultimately must infer by the relationships among spacetime constants. Little things like this are major speed bumps to progress, especially when everyone is trying to find simple generalizations. Be sure to hit like and subscribe to see future videos. Thank you.